Good morning. This is my first attempt at a Screencastify use of Screencastify to put a video out there. First thing we're doing is we're going to do the normal distribution notes for day 6 of the stats unit. If this goes well, then hopefully we'll be able to do a whole bunch more things. Just excuse all the random noise in the background. It's not a completely quiet environment here. So if you would go ahead and get your day 6 normal notes and we'll start going through. So this drawing shows you some things about all standard normal distributions. The area that we have in between the cursor right there is on the mean. That's the center of the normal distribution. It has a little letter here, looks like an M. That is mu. That's the same thing as X bar. Mu is for a population, X bar is for a sample. But from now on, mu, X bar mean the same thing. Okay, and then we have a standard deviation, which is S, but that's the lowercase sigma. Looks like a circle with a little top to it. That's the lowercase sigma. That means standard deviation. So what we have here is we have a normal distribution, and when we go one standard deviation to the right or one standard deviation to the left, this area under the curve is approximately 68% of the area, which means if something is normally distributed, like the weights of infants or some other thing that happens in nature, then 68% of the data will be in this section of the curve. Be one standard deviation within the mean. If we go out another standard deviation, that area under the curve is not as big as the areas before. And so we don't add 68%. That total from here, the left side, over to here, the right side, that'll be 95% of the data. And then if we go out 3 standard deviations from here to here, it is 99.7% of the data. Excuse me there, I was having a little bit of issue. There we go. Now we got it going. Okay. So here is our standard normal distribution. And again, this was our mean. This is one standard deviation. So this area, remember, was 68%. So that means this has 34% and this has 34% of the data. That's 68% divided by 2. And if we go out one more standard deviation, then this area picks up 13.5% of the data, and this area picks up 13.5% of the data. That gives us 95% of the data right there. Remember, the other one was 68. trying to learn how to write with a stylus. Kind of fun. Anyway, that's 68%. And then what we're going to say is that the remaining part of the tail is 2.5%. Okay? So anything beyond 2 standard deviations is going to be considered to be 5%. Outside of the 95% from here and here, that's going to be a total of 2.5 on the right, 2.5 on the left. That's 5%. So there's 5% of data outside 2 standard deviations. There's 95% inside. Let's take a look at the first problem. Here we go. So it says the heights of 8-year-olds are normally distributed with a mean of 50 inches and a standard deviation of 2 inches. So mean or x bar, same thing. Okay, mu or x bar, that was given as 50. And then the standard deviation, S, or that little circle, sigma, that's the same thing, and that's 2 inches. Okay, so we have a standard deviation and mean for a normal distribution. So the 50 will go right here. When we go 1 standard deviation to the right, and I think it's just a tick mark down here on your notes, what you'll do is you'll go 2 units to the right, so that will make this 52. And go 2 units to the left, that will make this 48. Well, another standard deviation either way, that will go 54. And 46. Lost my train of thought there. Hold on. When I mess up, I actually can get rid of things. There we go. 46. Okay. And if we go out a third standard deviation, we can go to 56 and 44. Messing up left and right. There we go. Okay, so what said, what percent of 8-year-olds are taller than 50 inches? So what I'm going to do here is I'm going to color in all the sections that are greater than 50 inches. So that section is greater than 50 inches. Well, that's greater than the mean. Remember, this is a symmetric curve, so that means there's 50% of the data is greater than the mean. So the answer to A is 50%. Next question, B. What is the probability that a randomly chosen 8-year-old is between 48 and 52 inches? Okay, again, I'm going to color in the section that's between 48 and 52 inches. If you remember, one section to the right and one section to the left, or one standard deviation to the right and one standard deviation to the left, that was 34%. Total there is, of course, 68%. So that is 68% for B. Answer C. What is the probability that randomly chosen 8-year-old is between 46 and 54? 46 would be here. Oops, wrong one. Again, all the way over to 54. Well, that looks like that's 2 standard deviations to the right and 2 standard deviations to the left. So that would be 95%. So 95% of the data is between 46 and 54 inches tall. Okay, last question, D. What percent of 8-year-olds are shorter than 50 inches? Shorter than 50? Be all of that. Okay? So that looks like that is everything on the left half. So that would be 50%. Let's go to the next problem. Of course, anytime that you need to pause this video or you need to go back to catch something that you didn't catch, please do so. The weights of newborns are normally distributed with a mean of 7.5 pounds and a standard deviation of 1.25 pounds. So we have X bar or mu be 7.5 and a standard deviation of 1.25. Go ahead, pause the video after you draw the standard deviation, or the normal distribution curve. Go ahead and figure out exactly what these tick marks, what values they should have. Remember, those tick marks go for the mean, 1 standard deviation to the right, or 2 standard deviations to the right, 1 standard deviation to the left, and 2 standard deviations to the left. Go ahead and figure out what the numbers are for each of those. Go ahead and pause the video, do that, and then I'll be back with the answers in just a second. So 7.5 goes here. If I add 1.25 to that, that'll be 8.75. This will be 10. So I added 7.5 plus 1.25. That's 8.75. 8.75 plus 1.25 is 10. 7.5 minus 1.25 is 6.25. And then 6.25 minus 1.25 is 5. Okay, so let's answer the questions. A, what percent of the newborns weigh less than 8.75 pounds? So 8.75 pounds would be there, 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 and there. If I go ahead and write up that this was 13 point, excuse me, not 13, what am I saying? That's not correct. This would be 34%. And then everything left of the 7.5, anything less than the 7.5 would be 50%. So from here all the way to here, that's 50%. That's half of the data plus this section of 34. So that would be 84%. Again, that would be the 50 plus the 34. So 50% of the data to the left of the mean, to the left of X bar, and then 34% for that first section, which is half of the 68 between all the data between plus or minus one standard deviation of the mean. The right half there is just half of the 68, so that's 34. So 34 and 50 is 84. All right. I've successfully erased all of that. Now let's go to B. What percent of newborns weigh more than 10 pounds? Weigh more than 10 pounds. Wow, that's way up here. That area is very small. And so you're going to come up with a very small number. If you remember, we decided to go out to one standard or excuse me, just to two standard deviations. And so this area all the way there to here was 95. And then we left the two tails. Now, anything outside of 95% would be 5%. So the tails here and here have to split 5%, which makes this 2.5% here and 2.5% for the lower tail. So anything greater than 10, what percent of newborns weigh more than 10 pounds would be 2.5%. All right, next question. C. What is the probability that a randomly chosen newborn weighs between 5 and 6.25? 5's over here and 6.25. So it's just this section right here. If you remember from before, this was 34%, this was 34%. The next level out was 13.5%. So this section, it's the section between one standard deviation and two standard deviations less than the mean. So 13.5% would be the answer for C. All right, last question for, oh, second to last question. There's a D and an E on this. So D on this. Okay, so D on this. What is probability that randomly shows newborn weighs between 6.25 and 10 pounds? 6.25 and 10. So 6.25 would be 34 and 34. Remember, that's one standard deviation between left and right of the mean. That's a total of 68. So 34 and 34 is 68. And then this section is 13.5. So 34 and 34 is the 68 plus the 13.5. I believe that's 81.5%. I've been doing these calculations for a very long time. I've got this curve and these numbers absolutely memorized. It makes it lots easier when you do so. You're going to see 81.5 a lot. You'll see 68 a lot. You'll see 2.5 a lot. You'll see 16% a lot. So there's a lot of numbers that just keep coming up when you're asking questions like this. So E. In a group of 5,000 randomly selected newborns, about how many would you expect to weigh less than 6.25 pounds? All right, let me get rid of everything we've had up here. We'll address the 6.25. Okay, again, less than 6.25 pounds. So that's this section. So remember, this is 2.5, and this is 13.5. So you add those two together, and that's 16%. So 16%, but it didn't ask for a percent. It asked for about how many people would you out of 5,000. So it's 16% of 5,000. So you take one, or you 0.16, and you multiply it by 5,000. And unless I'm misremembering, I believe that is 800. Okay, so that's the first two questions on the notes. Please take some time now, pause the video, and try number 3. The scores of an IQ test are normally distributed with a mean of 100 and a standard deviation of 15. Please try that problem, and we'll see where we are. So go ahead and pause the video and try that problem. Remember, X bar is mu, and S is sigma, standard deviation. So 100, one standard deviation left and right, gives us 85 and 115. That's 100 plus 15 and 100 minus 15. It's also two standard deviations, gives us 85 minus 15, which would be 70, and 115 plus 15 is 130. So A, what percent of IQ scores are between 85 and 115? Between 85 and 115 is one standard deviation. That is 68%. We might be able to remember that now. B, what is probability that randomly chosen IQ score is between 100 and 115? 100 and 115, of course, is right there. So just that section is going to be 34%. C, what percent of IQ scores above 145? That's a tough one. Let's go and do that one real quick. That's going to require us to go out to a third standard deviation. We'll get to that in a second. So that puts us here. We didn't have to do that on the last couple problems, but we can address that now. We just said it was 2.5% above two standard deviations, but there was a third standard deviation which pushed it at 99.7. Okay, again, that's 99.7. Sorry for my sloppiness there. So that gives us 0.3% in each, or to split among the tails. So if you divide that by 2, it's 0.30 divided by 2. 0.30 divided by 2 is 0.15. So there's actually 0.15 in this tail going forward. And then there will be 0.15 in this tail going less than. So above three standard deviations above the mean gives us a percentage of 0.15. So it's 0.15%. Not 15%, but 0.15. So there's very, very, very few people that have an IQ score above 145. I'm probably not one of them, considering I can't draw on an iPad very well. But hey, trying. In a group of 7,000 randomly selected people, let me get rid of a whole bunch of this stuff now. Okay. In a group of 700 randomly selected people, about how many would you expect to have IQs between 70 and 130? So I'll highlight 70 and 130. So that's two standard deviations left and right of the mean. That gives us 95%. So we're looking at 95%. If you wanted the individual sections, that's 13.5, 34, 34, 13.5 again. Add those up, you should get 95. Seven thousand randomly selected people, about how many would you expect to have IQs between 70 and 130? So we need 95% or 0.95 times the 7,000. Don't know that one right off the top of my head. $66.50. So the correct answer for D is 6,650 people.